Which of the following alkenes are trans isomers? So cis and trans, we've encountered these terms with cycloalkanes. And so we have cis and we have trans. And like for cycloalkanes, these, when we use this terminology for alkenes, we can only apply this to di-substituted alkenes. So only di-substituted alkenes can be described this way. So it's kind of an older terminology, but it's still used quite commonly, and it's still part of some common names that are generally used, so we want to be familiar with it. So the same as this meant for cycloalkenes, cis means both pointing in the same direction and trans means pointing in opposite directions. And so what we're going to be focused on here is, you could look at the substituents, but the technical definition is what you're looking at is you are comparing the hydrogen atoms on each carbon of the alkene. Okay, and so when we're saying what side of the alkene, we are bisecting the alkene right through that pi bond in each case. And so we see in the first one, we have hydrogens, and these are on opposite sides, so that is trans. If we look at 2, we've got hydrogens on opposite sides, so that is again trans. And then if we look at the third one, we have a monosubstituted monosubstituted alkene, so we don't have cis or trans. So the substitutions on the alkenes means, look at the alkene carbons, how many things do you have that are not hydrogen? So only one would be mono. Here you have 1, 2 things that are not hydrogen, so that's why that's di. And on number 1, you have 1, 2 things that are not hydrogen, so that's also why that's a di-substituted. So your monosubstituted alkenes don't have stereochemistry. So we don't have to worry about stereochemistry here. So that means that we are looking at 1 and 2. So that is option C.